We can approach cosine of x, y equals cosine of x, in a similar fashion. Again, we'll really get the points that you need to draw a pretty good sketch of this graph if we go around the unit circle on what they often call the quadrantal angles, the ones where you land between quadrants on an axis. So if we use 0, pi over 2, pi, 3 pi over 2, and 2 pi, again, we'll have the x-intercepts and the max and min points for cosine. Cosine, the graph actually looks the same as the sine graph if you do a horizontal shift. We'll see more about that later. But if we cut it off from 0 to 2 pi, which is typical because the period's 2 pi, you get more of a U shape on the graph. So here are the points plotted as you go around. If you look at the x-coordinate on the unit circle, at 0 it's 1, at pi over 2 it's 0, at pi it's -1, 3 pi over 2 you're back to 0, and at 2 pi the x-coordinate again is 1. So you get this sort of a U shape, and it's not a V, it's filled in with nice smooth humps. And there's the graph of cosine, which again is periodic, and it keeps repeating that shape over and over, so you get these waves going up and down over and over. But on one complete period you see basically the U shape. So for our first example we're going to work here, we're going to do a couple of transformations. We're going to graph y equals sine of t, and then 3 plus sine of t, and negative sine of t, which we should recognize from our work on functions in general as just a couple of transformations, and that's how we're going to come up with these graphs. Okay, so I'm going to attempt to do this on my iPad with the Apple Pencil for the first time, so this will be trying something new for me here. So let's start with y equals sine of t or sine of x. Let's go ahead and call the input variable x. So again, this is the basic graph we just saw, but I could start with the points, make a table here. The 5 points, we could go around the unit circle: 0, pi over 2, pi, 3 pi over 2, 2 pi. And the sine values would go from 0 to 1 to 0 to -1 to 0. So one complete period of sine. Here's kind of my systematic way. I'm going to draw more of the T shape on the axis here, and then 1, 2, 3, 4 tick marks out to 2 pi. So if we label them all, we have pi over 2, pi, 3 pi over 2, and 2 pi. And what we call the amplitude of the sine graph is 1. It bounces between -1 and 1, so I'm just going to label that on my y-axis. And let's see, let's change color here. So we could plot our 5 points. So I'm going to overlap the label there a little bit. But one hump going up, one hump going down. There's y equals sine of x. Okay, now if we wanted to do 3 plus that, say we want to graph y equals 3 plus sine of t or sine of x, whichever we want to call our input variable, that is just a vertical shift up 3. Let's see, I'm going to need more space on my y-axis to do that. So 2, 3. I'm actually going to need to go up a little bit higher. Okay, so figured out how to add space there. Okay, now I'm going to color code here and go back to green. So if we take each of these points and we move them up 3 spaces, we're going to get a vertical shift of our sine graph, which will bounce between 2 and 4 now. Of course, it's periodic. It would keep on going forever, but there's one complete period of sine of x and then 3 plus sine of x. And then if we were to go ahead and add to this same picture the last one here, let's see, in red I'll do y equals negative sine of x. Well, that's going to be the reflection across the x-axis. So if I change the y values on my 5 points on the blue graph and reflect the graph, we get y equals negative sine of x.